The last time I saw you guys, we were talking about evaluating expressions. And I almost feel like this lesson should come before that lesson, but I mean, it doesn't really matter the order. But today we're talking about the parts of expression and what makes them up. And then the other thing we're talking about is combining like terms. And so when we get into this, it's almost like vocabulary more than it's like an assignment. You know, it's like breaking down the vocabulary, at least the first part where we're talking about the parts of the expression and where we're going to have you break them down into a chart. If you look at this expression that we have on the Mighty Thor's note page, um, we have this 9x minus 2 plus 16x plus 8 minus x plus 10. A lot of things are going on in here, right? The parts of the expression, though, the variable terms are all of the parts that just have a variable with them. So if we looked at the variable terms, we would have 9x is a variable term, 16x is a variable term, minus x is a variable term. And the reason I put the minus on it is that that's like saying negative 1x, right? So we're going to leave it there as a variable term. It is a term that has a number that has a variable attached to it, or just the variable itself, right? If like I just had an x there, that would be a variable, and that would be a variable term. The constant terms are all the terms that don't have a variable. They don't have an x or a y or whatever value related to it. And so they're just our numbers, like our regular numbers, right? In this case, negative 2 would be a constant term. 8 would be a constant term. Hey, Mighty Thor needs to know math too. But today he's taking advanced space pets, and the topic will be puppies. Hey, I didn't say I wasn't silly sometimes. The more ridiculous, the better. And it's the Mighty Thor. Who doesn't like the Mighty Thor? Well, it's definitely not today because we don't have an advanced space pets course today. Coefficients. What are coefficients? Does anybody know? Well, it says so on there. So can anybody read? Yes, Leah. And, oh, it's small? Number next to the variable. Let me make it a little bigger for you guys too. Does that help? So it's the number next to the variable, and we listed all our variable terms already, right? Which were 9x, 16x, and that negative. If we're listing our variable terms, they would, I mean, our coefficients, they would be 9, 16, and that negative would represent negative 1, right? We don't really write it when we have a 1, but we know it's there, right? It's saying that there's 1x, and we don't have to write how many there are because there's just one and you can see it. So when we're breaking down our examples, we're really just charting, right? We're just like separating these things by which are variable terms, which are constant terms, and which are coefficients. So if we look at the first one, we go, okay, well, our variable terms are anything with a variable, anything with a letter. So our first one is going to be 8a, and then we'd have 2a, and then nothing else has a letter attached to it. Our constant term is the one that doesn't have any letters, right? So negative 3. And then our coefficients are we just take our variable terms and whatever number is in front of them. Yes, Jason. That is a 2. You're welcome. It was a good question. And so we're going to take whatever numbers are in front of these variable terms, and they are our coefficients. right? And so it would just be 8 and a much better drawn 2 this time. And so we can do this on all of these problems, right? We can look at number 2 and we can see that our variable terms are just the terms that have the letters attached to them, right? So we'd go, okay, the first one is x, and then the next one would be minus 3x, and that's it. Those are all of the variables that I have, so that is all of my coefficients, right? I mean, all of my variable terms. My constant terms are any numbers that are left. So we have negative 12 and 22. And our coefficients are just the numbers in front of the variables. If we look at this one, we have this x there. It has an imaginary 1 in front of it every time we see it, and then the other one would be minus 3. So we don't want to forget. What's that? Yes. Is it not showing up big for you guys, or is it just illegible today? Oh, okay. You can kind of tell by the problem that we're looking at because it's whatever variables inside those problems. Because we're taking them out of these expressions, right? So it's going to be whatever is in there. So is this making kind of sense though? Like none of this is too difficult, right? We're just taking apart all of these pieces. You're welcome. All right. So if we look at number 3, we could see whatever they are, right? We go, okay, well, we have this minus 19a. That is going to be a variable term because it's got a letter attached to it. Now I know that's an ugly minus 19a, so I'm saying it. It's minus 19a. The next one that has a letter attached to it is this 2b, so 2b would be our next variable term. And then we only have one left, and that is 6a, right? And that's all the variable terms that we have, right? There's nothing else that has a letter on it. It's pretty much most of our terms in this one were variable terms. So now we would move on to our constant terms, which are just the numbers that are all by themselves. And the only one we have like that is this negative 10 right here. And so our constant term is going to be negative 10. Our coefficients are just the numbers in front of our variable terms. So we're going to look at each variable term we wrote, and we would just write in this column negative 19, 2, and 6. Those would be our coefficients. And the reason that we do this is because we're going to be moving into combining like terms. And each one of these categories kind of breaks down our like terms. So number 4, I have 15m, I have n, and I have negative 7m. And those would be my variable terms. Each piece of that separates our terms. So here we would have 15m. Yes, Caitlin? Sure. So for the coefficient, that part, that's a good question. See how we just have an x there on the first variable term? There's always like an imaginary 1 there because you have to have at least one x for it to exist, right? And we don't ever write the 1 in front. Like, so if we looked at this whole equation, right, technically this is 1x because there's nothing up against it. But when we multiply by 1, we just get that value anyways. So we never write the 1. but there's still one x there, right? There still has to be one x there, because if there's not, then there's no reason to write it at all, right? But there's still one x at whatever that value is. So if you don't have anything in front of it, that coefficient is just 1, right? If you remember when we went up here, when we had the minus x on this one, we just wrote it as -1 down below. Do you remember that? Does that make some sense to you? All right. So if we look at number 4, we've got 15m, we've got plus n, so technically that would be 1n, and we have minus 7m. And then our constant term is the only thing we have there that doesn't have a variable on it, which is just 9, right? And then we can, when we look at our coefficients, it's going to be the numbers in front, but if there's not a number in front, it's just 1. So we would have 15. We would have, where this n is, it's just going to be 1. And then on this last one, we're going to have minus 7. And those are our coefficients. I'm going to give you a second to write it all down, because we're about to move into some crazy stuff right now, right? We've got double variables. But it doesn't get any crazier. It's really just as easy as what we've been doing when we go to break it down. Liam, turn your camera on. Adele, turn your camera on. Chanel, turn your camera on. Thank you. Now, when we move into this next problem, we can like look at each piece. We go, okay, well, here I have -12. That's a constant, so I'm going to write it under the constant term. This next piece, I have this plus xy. Xy is our variable term, right? How many xy's? 1x, 1y, right? So our coefficients would be 1 on them, but right now it's x times y. If we look at our next term, well, that's just 9, so that's going to be a constant, right? And if we look at our next one, it's minus 2xy, and that is a variable term because it's being multiplied time. That -2 is being multiplied by both pieces. They're all multiplied together. And when we go to write our coefficients, this xy, this first one that we have that had no coefficient in front of it, no number in front of it, will just get a 1. And the other one will get a -2. And I'm trying to look at something that might make this more complicated, that makes me have to complete this chart. But at this point, I don't see any reason to complete this whole chart. You guys are getting the general idea of it. I think I'm going to skip these two. I'm going to do number 8, though, just because there's one little difference in there. So we're going to skip 6 and 7. And we're going to come down to number 8. And the reason for that is we have a couple things going on, right? I have an m, right? Then I have 7mn, and then I have a minus m, right? Each of those is a constant term, and they're separate from this m inside here. It'd have the same value, but it's a separate term. And then for our only constant, we would have a 12. And with our coefficients, this first m would be a 1. The next, the mn, would be a 7. And then the minus would be -1. And we can't combine this m with the other m's. But the whole reason for going over this is it kind of teaches us the different piece. Every piece between those plus and minuses, right, creates a term, right? Because anything that's multiplied together can be one term, but adding and subtracting are separate terms, if that makes any sense at all. And the reason that we've done it is because we need to talk about combining our like terms, right? And we know what terms are now. And I noticed that it's starting us with this same expression that we'd had in the beginning, right? This 9x minus 2 plus 16x plus 8 minus x plus 10. A lot of pieces, right? Yes, Caitlin. That one? So it says you can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. Anything that has the same exact variable can be combined together, right? We can add or subtract those variables. They have to have the same power, right? And they have to have the same variables. So like if we looked at number 8, we can't combine m with mn, but we can combine it with the other m. So if we look at this expression that they're giving us right now, all of these x values can be combined. We have this 9x plus 16x minus x, and we can combine all of those. And the way we would do it is we would add or subtract their coefficients, right? So here I would have 9 plus 16, that's 25. And then minus 1 would be 24. So I would have 24x. And then we can take all of our constant terms and combine those. So our constant terms, remember, are just the numbers that don't have any variable. So we could take all of those terms, which are minus 2 plus 8 plus 10. And we can add or subtract those together depending on what it's asking for. So we have minus 2 plus 8, well, that's 6. Plus 10 more, that would be plus 16. And we have simplified that expression, right, to a much, it's the same thing. They have the same value. We just made it a much shorter statement, right? We only have 24x plus 16. And so we're going to do some examples where we're combining our like terms, right? We're going to look at what is similar that we could combine. And if we look at this first problem number 11, we go, okay, well, we have two values that have p, right? And because they have that same variable, we can add those together. And we just add their coefficients. We'd add 4 plus 8, which is going to give us 12p. Now, this 10 doesn't have anything that can be added to it, right? It's the only constant that we have. We don't have other just plain old numbers there. So our whole thing would just become 12p plus 10. Does that make sense? A little bit? See anyone nodding. I also don't see anyone shaking their head. Jason just came back into the picture to go, yep, Miss Y, I totally get it. Let's look at the next one. We've got a couple of x's. We've got a couple of constants. There's multiple things that can be combined on this one, right? I have my x values right here. I have 2x and I have my minus 14x. And because they both have an x and they're just an x, right? we can add those coefficients or subtract, as the case may be in this one, because it's 2x minus 14x. And we just look at the coefficients and we go, okay, well, 2 minus 14 is minus 12, and then we put the x there. And once we've done that, we can move on and we can look at, oh, well, my constants, that leaves me with this 12 and this 8. And I can combine those together. 12 plus 8 is 20. And this is our simplified version. We've combined all of our like terms. And this is going to be very important as we move on in this class, because you guys are doing like basic algebra right now. This is like pre-algebra stuff, you know, and it's one of those things that's going to come back every year for you. So if you can nail it now, you guys are at a huge advantage. Number 13. Anyone want to take it on? Anyone want to try it? No volunteers? Well, let's look at our A's. Next one, though, I'm going to call on someone, so I don't get a volunteer. Here I have A minus 4A. That's like saying 1 minus 4. You have the answer? All right. What's 1 minus, what's the answer, Daniel? Tell me the answer. I think it is, right? Let's look at this. We have A minus 4A. Well, 1 minus 4 is minus 3. So there's that minus 3A that Daniel gave us. And now we have, what we're left with is this minus 7 plus 2. And that's going to give us, he said negative 5, but I wrote it as positive 5. And I was wrong and he was right. Because negative 7 plus 2 gives us negative 5. Good job on that one. If we look at number 14, we have different variables. We have multiple variables, right? But we can combine our R's together and then we can combine our S's together. So we can look at this and we can go, well, here I have R plus 2R. Well, that's 1 plus 2 is 3R. And then we can do the same thing with our S values. We could go minus 2S minus 8S can be combined. And minus 2 minus 8 is negative 10S. Well, now my S's look like 5s. Before my 2's look like Z's, and now my S's are looking like 5s. So I'm trying to see if anything gets harder as we move down this sheet, because there's no reason to do all of them if they don't give us something crazy at the end. And I'm looking and I'm looking. I am going to skip, like, let's skip these right here, and we'll move down to the harder ones at the bottom so that we can kind of, none of them get all that hard at the bottom. But let's do 25 and 26, and then we'll call it quits. Okay? So here I have some D's, and I'm going to combine anything that has a D. Why did I pick that first? Because it's the first thing I saw. So I have 10 minus 4, 10 minus 14, which is minus 4D, right? Then I have another variable. It's this 5F, but there's no other F's. So I'm just going to leave that alone as plus 5F, right? And then I've handled everything with variables. So I'm going to look at just my constants now, and I'm going to go 5 minus 12 is minus 7. This can never be combined more than that, right? We can never combine that D with the F because they're not like terms. And if we look at this one, we've got two variables, right? I have this 10y, so I'm going to combine it with the 6y. 10 plus 6 is 16y. And then I'm going to move on to the next variable, right? Normally we do variables alphabetically, but it doesn't really matter right now. So I'm going to go 25x plus 5x. 25 plus 5 is plus 30x. And the only thing we have left is this 13 right here. It doesn't have anything to be added to it, so we're just going to add 13 at the end. And your worksheet on your homework, you're going to have to fill out a chart where you're separating the variable terms and the constant terms and the coefficients. So you're going to have like a chart like that, just like we did up at the top. And then you're going to have some problems where you have to just combine your like terms. So I don't think that it's too difficult, but if you do have questions about it, I'll have tutoring open at 2 o'clock today. If you feel good about it, I'm going to let you go now. If you don't, though, if you have questions or you want me to scroll up and you want, yeah, just give me a second on that. If you need to stick around to complete the notes, just let me know, just like Chanel did, so that we can make sure you have the ability to see all of it before you go. But they will be posted in Google Classroom before I leave this class today. Yes, Jackson first. Yeah, but you were able to get in the other day for the. All right, stick around, Jackson, because we've got a few minutes. I'm going to have you log in, but I just want to give everyone a chance to get these examples down. Chanel, how far do you need me to scroll up? And anyone else can go if you don't want to, if you're done. Bye. Thank you. Thank you, Daniel, too. Bye, guys. Chanel, where do you need it? Bye, Jason. Like, am I up too high or you need to go to the top? Yes, you can leave. So, everybody get the notes done? I can't look at talk you through it, Jason, until we um until I can share screen with you. Actually, maybe I'll just open up the chart part. That part or the very part right here? Okay. You are very welcome. Yes, Eliza. Um, well, it depends on if you like if we look at this top term right here for our example one, say I'm doing the x's, right? 9 is positive and I'm adding it to 16. So that's plus 25. And then I'm subtracting 1 because this one is negative. So that would be at 24, right? But if we looked at, so that one would be a positive 24, right? It would be plus 24x. It just depends on what you come up with. If we look at negative 2 plus 10, that gives us 8, and 8 would be positive. right? So it depends on the solution that you get when you combine them. Okay, so you're saying like if you had two different variables? Okay. Is everybody good with copying this so I could scroll a little bit for all right. If we come down to, I'm just trying to find something with so if we look at number 14, right, we have two different variables and I'm just combining my r's. So I have r plus 2r, so that's 3r, right? 1 plus 2 is 3. So we have this 3r. And then on this one, I have minus 2 minus 8. Well, that gives me minus 10. And that's how I know whether or not I'm going to add or subtract that. Yes. Yes. No worries. Just make sure you get your form in so you can get the full credit. But thank you for letting me know. Where are you going? Where are you? Oh, I didn't know that. Cool. All right. Thank you for letting me know. Bye-bye. All right, Jackson. Is everybody done with the notes now? Okay. So you too, Caitlin. Thank you.